right, so today we're doing a little bit of a review. So we're covering the distributive property and some more algebraic expressions. So let's look at this packet, the front part of it. We're using the distributive property to simplify algebraic expressions in a little bit. Now we're just simplifying, we're simplifying, what did I say? Algebraic expressions. So if I look at 7 times n plus 5, remember if I'm distributing, I have to distribute that 7 to my m and to my 5. When I distribute them, that means I'm multiplying them together, and I'm keeping my plus sign in between the two. So I have 7 times n plus 7 times 5, which simplifies to 7m plus 35. Okay. The second one's a little bit different. We have 3 times n minus 8. So just like when we were subtracting integers, we always changed our subtraction problems to addition problems. This is kind of the same thing. When I'm using the distributive property, I prefer to leave it as a subtraction problem, but our notes change, or I prefer to leave it as subtraction. Our notes change it to addition. So you can do whichever you want. Right now we're going to look at the addition one, and then we'll do it as a subtraction problem as well. So they distributed their 3, but before they did that, they changed it to an addition problem. So remember that if we're adding a negative, that's the same as subtracting. So n minus 8 is the same as n plus negative 8. So that's all they did was just change it to an addition problem. And then they distributed the 3 to both numbers. So we got 3 times n plus 3 times negative 8, which simplified to 3 times n plus negative 24. And then just like I said, plus adding a negative is the same as subtracting. So 3n minus 24. So that's if you change it to an addition problem. If you want to change it or keep it as a subtraction problem, you can. You just kind of have to be a little bit more careful, especially if your number is over here on the right side. So you're still going to distribute your 3 to your n and your 8. So you get 3 times n, and then you keep your subtraction sign. So minus 3 times 8, which is 24. And it gives me the same exact answer than I got if I just changed it to an addition problem. Okay? So whichever way you prefer, I'm fine with. But the distributive property is the only case where you can choose between what you like. When we get onto our second and third page of notes, you're going to have to change everything to an addition problem. Okay? But for the distributive property, you can choose what you like best. Alright, so let's look at number 1. I have 3 times d plus 4. So if I distribute that 3 to my d and my 4, that means I have 3 times d plus 3 times 4. And then I can multiply my 3 times 4. So I have 3 times d plus 12. Questions? Alright, number 2. My 4 is on the other side of my parentheses, but that does not change what I'm doing. I'm still distributing it to my 5 and my w. We've got a w minus 5, so if you want to change it to an addition problem, that's fine, but I'm going to keep it as a subtraction. So I'm going to multiply my 4 and my w first. So I have 4w, keep my subtraction sign, and then 4 times 5, which gives me what?
20.
So I have 4w minus 20. Questions on number 2? Alright, number 3. I have a negative 2 times a c plus 7. So I'm still distributing, but I have to distribute that negative 2. Not just 2, but my negative 2. So when I distribute it, I get negative 2 times c plus negative 2 times 7. And then I can simplify. So negative 2c plus, what is negative 2 times 14? Negative 2 times 7?
Negative 14.
negative 14. Am I done simplifying, or can I go further? What is the same as adding a negative? Subtracting. So I can rewrite it as negative 2c minus 14. And then I don't have any parentheses. Alright, number 4. I've got 9 times b plus 4. So if I distribute, I've got 9 times b plus 9 times 4. And simplify it, I get 9 times b plus, what's 9 times 4? 36. Number 5, I've got p minus 10 times 8. So I'm still distributing my 8. So I get 8p. I keep my subtraction sign. And then 8 times 10. And when I simplify, I get 8p minus 80. Questions? Number 6. Negative 11. Remember, we're distributing the whole entire term of negative 11. So I get negative 11g minus negative 11 times 6. When I simplify, I get negative 11g minus, what's negative 11 times 6?
Negative 66.
Negative 66. Good. What do two negatives beside each other make? A positive. So that means I can write it at negative 11g plus 66. Sorry. So remember that those two negatives right beside each other make a positive. We good? Number 7. Got negative 14 times j plus 3, so that means I have negative 14j plus negative 14 times 3. So what's negative 14 times 3? 42 or negative 42? Negative 42. Am I done? What do I need to do, Ashlyn? Okay, so negative 14j minus 42. Good. Number 15. I'm multiplying my 20 times 15. Keeping my subtraction sign. And 20 times a. What is 20 times 15? 300. So I get 300 minus 28. Number 9. When I'm distributing, that gives me 9 times 50 plus 9 times h. What is 9 times 50?
450.
450 plus 9h. Alright, y'all go ahead and do these last 6 on your own, and then we will go over those answers. we still working? All right, what do we get for number 10?
60 minus 5.
Yes, 60 minus 5c. What was your other way? It's going to be, which I read it wrong too. If you do it the other way around, it would be negative 60 plus 5c. Right? $60 minus 5c. And Max, what did you say? 60 minus 5c. What do we get for number 11? Negative 12s plus 24. By number 12? Good. What did you get for number 13? 20y minus 260. Number 14? Good. Negative 60 minus 15n. And number 15.
Wait, if we do it the other way around, 14. No. Okay.
What other way around, Max?
Wait, negative 15 and minus 60.
Yes. Yeah, you can do that. Do you have a question, Cole?
Oh no, I was asking what
Questions on this first page? Flip over. Let me finish the lesson, and we'll go over it. All right, so we've got 4 vocab words. Some of them you were introduced to a couple months ago, first couple weeks of school. So we've got term, coefficient, constant, and like terms. So a term is a number, variable, or product of numbers and variables. Terms in an expression are separated by addition or subtraction signs. A coefficient is the number part of a term that contains a variable. So you can't have a coefficient if you don't have a variable. Okay? So it's always going to be that number that's right in front of that variable. A constant is a term without a variable. So just a number by itself. And like terms are terms that contain the same variable. So if I have 2a plus 3a, they are like terms because they have the same variable of a. So you can combine them by adding. If you have 2a plus 2b, you cannot combine them because you've got an a as a variable and a b as a variable. So they're not like terms. Okay? So let's look at this example. We have 6a minus b plus 2a minus 7. All 4 of those numbers are called terms. Okay? My like terms are 6a and 2a because they share the same variable. And then 7 is a number by itself, so it's called a constant. Over here, we have coefficients of 6, -1, and 2. Let's look at negative b right there. They said our coefficient of b is -1. That's because remember that we have a understood 1 in front of any variable. If the variable doesn't have a number in front of it or a coefficient in front of it already, you have to understand that there's a 1 there. Okay. Questions? Okay. Let's look at this example. We've got 4m minus 5m plus n minus 7. So the first thing we're doing is changing this whole subtraction problem into an addition problem so that we don't confuse our coefficients. If I were to ask you what the coefficient of my 5m was, what would you think it is? My coefficient. 5, right? But it's actually negative 5 because that's a subtraction sign in the front. So that is exactly why we're going to change it all to addition problems so that we don't confuse it. Okay? So we're going to change all of our subtractions just like when we were subtracting integers. You're circling that minus 5m and adding an addition sign in between. Same with my minus 7. So that when I rewrite it as an addition problem, I have 4m plus negative 5n, or 5m, plus n plus negative 7. So it's a lot easier to tell my coefficients when I rewrite it that way. So if we look at our terms in this problem are 4m, negative 5m, 1n, and negative 7. They left off negative 7. Okay. So all four of these numbers are called terms. My like terms are my 4m and my negative 5m because they share the same variable. My 1n does not have a like term because it's the only term in there with a variable of n. My coefficients are 4, negative 5, and 1. And my constant is negative 7. So let's identify some of these on our own. All we're doing here for 1 through 6 is identifying the terms, like terms, coefficients, and constants. This problem is already an addition problem, so I don't have to change it. So what are my terms here? Anybody tell me? Henry. All three of them. So I have 2, 6a, and 4a. What are my like terms? 6a and 4a. Good. What about my coefficients? Six and 4. My coefficients are those numbers in front of the variables. So it's 6 and 4. Do I have a constant? What is it? Good. My constant is 2. So my like terms share the same variable, and my coefficients are those numbers in front of my variables. Let's look at number 2. What are my terms? Good. M, 4m, 2m, and 5. What are my like terms? 4m and 2m. And what else? M, 1m. So don't forget that in front of that m is an understood 1. What are my coefficients? Good. 4, 2, and 1. Do I have any constants?
Yes.
What?
5.
Good. Constant is 5. Any questions so far? All right, number 3. I've got 3C plus 4D minus C plus 2. What is going to be my very first step here? Sam.
Switch it to an addition problem.
Good. We want to change this to an addition problem. So if I do that, I get 3C plus 4D plus what? Plus negative C plus 2. So all I did there was just change my minus C to adding a negative C. So now my terms are 3C, 4D, negative C, and 2. What are my like terms? What is it? What? I don't have any like terms?
3C.
Madeline.
3C and 4D and negative C.
My like terms. Addison. 3C and negative C. Remember that my like terms mean that they share the same variable. So D is not the same as my C, so that's why 4D is not a like term. They have to have that same exact variable with them. What are my coefficients?
3, 4.
3, 4, and what type of one? Negative 1. Don't forget that negative out front. What about a constant?
2.
2. Good. All right, number 4. What am I going to do first? Making an addition problem. So I have negative 4R plus negative 7 plus 6R plus negative S. So remember, we're circling that minus 7 and we're adding an addition problem in between, or an addition sign. Same with my negative S. So my terms here are negative 4R, negative 7, 6R, and negative S. What are my like terms?
4R and 6R.
Negative 4R, right? Negative 4R and 6R. What are my coefficients?
4 and 6.
4, what type of 4?
Negative 4.
Negative 4 and 6. One more. Negative 1. Because remember, in front of my S, that's a negative 1S. So it's a negative 1F. Do I have a constant? I don't?
7.
Negative 7, right? Look up at the second problem that we wrote. This is a negative 7. Alright, number 5. I've got some subtractions in there, so that means I need to go ahead and change it to an addition problem. So that gives me negative 12 plus negative 8x plus 8x plus negative 2z. So my terms are, negative 12, negative 8x, good, 8x and negative 2z. By my like terms, good, negative 8x and 8x. That's you. My coefficients. Okay, negative 12 is not going to be coefficient, right? Because it doesn't have a variable tied to it. But negative 8, 8, and negative 2, all three have variables with those numbers. So that's what makes them coefficients. So I have a constant. Negative 12. Number 6, I have fractions. But it doesn't change anything. I'm already at addition problem, so I don't have to change it. So my terms are 4/7 A, 3/7 B, and 1/5 A. What about my like terms?
4/7.
Good. 4/7A and 1/5A. What are my coefficients? Good. 4/7, 3/7, and 1/5. What about my constant? Don't have any. No constants. Questions on this page? All right, flip over. Somebody read this first sentence for me, please. Amy.
If an algebraic expression has no like terms and no parentheses, we say that it is in simplest form.
Thank you. So if it's in simplest form, that means there are no parentheses and no like terms. So we are taking it as far as we can take it. Okay? So no parentheses, no like terms. To simplify these algebraic expressions, just like we just did, we need to write them as an addition problem. So if any of them have subtraction signs, we need to go ahead and rewrite them as an addition problem as our very first step. And then we're going to use that commutative property to regroup them so that we can simplify. Okay. So if we look at this first example, number 1, we've got 6x minus 5 minus x plus 7. So the very first thing that we needed to do is rewrite it as an addition problem. So I've got 6x plus negative 5 plus negative x plus 7. Remember that in front of that negative x is a negative 1x. So now we can use our commutative property to regroup so that our like terms are next to each other, so we don't forget about any of them. So I'm regrouping to get my x's beside each other. So I have 6x plus negative 1x, and then my constants, so plus negative 5 plus 7. When I combine those like terms, 6x plus negative 1x, I get 5x. And then when I combine my constants, negative 5 plus 7, I get 2. So my simplest form is 5x plus 2. I cannot do anything else. Unless they tell me what x equals, I can't do anything else to this algebraic expression. Number 2 has a couple more steps added in. I have 5t minus 7 times s minus 4t. So, the first thing I want to do here is change my subtractions to additions. So I've got 5t plus negative 7 times s plus negative 4t. What does this look like right here? What, Addison? The distributive property. So we're going to distribute that 7 to my s and my 4t. So like I said, when we first started these notes, I prefer to leave my distributive property as a subtraction sign. In our notes, they went ahead and changed it as an addition. So either way is fine with me, as long as you still get your correct answer. Okay. But we'll look and see how they did it. So they changed it to a plus sign and added that negative. Then they distributed that negative 7, and they got negative 7s plus negative 7 times negative 4t. Negative 7 times negative 4 gave them positive 28, so it's 28t plus negative 7s plus 5t. They regrouped their t's together. So they've got 5t plus 28t and negative 7s. So now they can simplify. So 5 plus 28 gave them 33t plus a negative 7s. Remember, if we want it in simplest form, we cannot have parentheses. So that's why we've got to change it back to a subtraction problem. So we got 32 minus 7s. Questions on that one? All right, let's do some of these on our own. So number 1, super simple. We've got 9m plus 3m. Are they like terms? Yes, because they both have the same variable. So we can combine them. So what's 9 plus 3? 12. So I get 12m. Easy as that. What about 5x minus x? What is in front of my x?
1.
That's a 1, right? So what's 5 minus 1? 4. So it's 4x. Alright, number 3. Do I have like terms?
Yes.
Yes, all 3 of them are like, right?
Yeah.
So I'm just going to add them. So what's 8 plus 2?
13.
10 plus 3.
13y.
So I have 13y. Good. Number 4, I've got 4 plus m minus 3m. What's in front of my m right here? 1. Is 1 smaller than 3? Yes. So remember, this is where I need to change it to an addition problem. So I'm going to circle my negative 3m and add that plus sign. So I have 4 plus m plus negative 3m. What are my like terms here?
M and negative 3M.
Good. M and negative 3M. So my 4, I can't do anything to it. But I can combine my M's. So what is 1M plus negative 3M?
Negative 2.
Negative 2M. Am I in simplest form if I still have parentheses? No. So I've got to rewrite it as 4 minus 2M. Yes, Elliot?
So here wrote negative 2 plus 4?
No. You left your M off.
Negative 2m plus 4.
Yes, that's fine.
I got to say the m.
Yes. Asia. Oh, I'm sorry. Guys. Questions on that? All right, number 5. I've got negative 15e plus 7 minus 5e minus 9. What do I need to do first? Jorge, I'm not sure what's funny. So quit laughing. Get it together. Desmond, what'd you say?
Change it to an addition.
Good. So I need to change it to an addition problem. So I get negative 15e plus 7 plus negative 5e plus negative 9. So now I need to combine my like terms. I need to use that commutative property to regroup. So what are my like terms? My e's. So I want to rewrite it so that they're all next to each other. So don't forget about any of them. So I've got negative 15e plus negative 5e plus 7 plus negative 9. Now I can simplify. So what is negative 5 or negative 15e plus negative 5e? Good, negative 20e. And 7 plus negative 9? Negative 2. Now I can rewrite it as a subtraction problem to get rid of those parentheses. Oops. And negative 20e minus 2 is my simplest answer. All right, let's look at number 6. I've got negative 8 times r plus 6 minus r plus 1. What does this look like right here? The distributive property. So let's go ahead and distribute, and then we can change everything to an addition problem. So if I have negative 8 times r, that gives me negative 8r plus negative 8 times 6 minus r plus 1. Okay. So I just copied the rest of my problem down, my minus r plus 1. What is negative 8 plus 6? Or sorry, times 6. Negative 8 times 6. Negative 48. So I have negative 8r plus negative 48 minus r plus 1. I need to change this minus r to a plus negative r. Okay. So I've got negative r plus negative 48 plus negative r plus 1. Now I need to regroup. So I'm going to regroup my like terms. So my like terms are negative 8r plus negative r plus negative 48 plus 1. So all I did here was just reorder my numbers. So I just combined my r's together, so they're next to each other, and then my constants. Now I can simplify. So negative 8r plus negative r is what?
9r.
Negative 9 or positive 9? Negative 9R. Plus, what is negative 48 plus 1? Negative 47. Good. Am I in the simplest form? No. I need to get rid of those parentheses so I can rewrite it as a subtraction problem. So I have negative 9R minus 47. And that is in simplest form. Questions on number 6? Alright, number 7. I've got negative 12c plus 3 minus 9 times 11 minus c. So let's go ahead and change everything to an addition problem. So I get negative 12c plus 3 plus negative 9 times 11. I'm going to keep this one as a subtraction sign because that's my distributive property. Okay. So I'm going to keep my subtraction problem inside of my parentheses for my distributive. So now I need to do my distributive property. So I have negative 12c plus 3 plus negative 9 times 11 minus, because I'm keeping my minus sign that's inside my parentheses, negative 9 times c. Now I need to simplify a little bit. So I have negative 12c plus 3 plus, what's negative 9 times 11? Negative 99 minus negative 9c. What about my minus negative 9c? What can I change there? Change it to a plus. Now I need to regroup. So I'm going to put my c's together. So I have negative 12c plus 9c plus 3 plus negative 99. Now I can combine my like terms, right?
Yes.
So my like terms are my c's. So it's negative 12c plus 9c. Negative 3c. Plus, what's 3 plus negative 99? Negative 96. And then to get rid of those parentheses, I can write it as a subtraction problem. So I have negative 3c minus 96. And that's my final answer. Any questions? There's quite a few steps to these problems. Yes, sir.
Could it end up being like
No, because we don't know what C is. So we can't just forget about our C. And we can't combine, we can't do negative 3 minus 96 because my 3 has a C with it. So really that's negative 3 times C plus, or minus 96. We just don't know what C is. Okay. Any questions? Alright, we're going to stop right here for today. This is as far as all my other classes have gotten today.
That's so limited.